Welcome to Unscripted with Jeff Pedowitz. I sit down with remarkable people from very different worlds, security and science, business and medicine, technology and the arts, for honest conversations about AI and where it's taking us. No scripts, no talking points, just what they actually think. I'm Jeff Pedowitz. Let's get into it.
Everybody argues about which AI model is best. Talukdar has spent 19 years building the very thing underneath the models, the data infrastructure that actually decides whether AI works. He helped build the data backbone of the process industry, the platform at one of the biggest enterprise AI companies, and the training data systems behind modern language models. Now, he's founded his own AI company. His view is blunt. The model is the easy part. The data and the engineering are where AI lives or dies. Manas, welcome to Unscripted. Let's get into it.
Thanks, Jeff. Happy to be here.
So as you've navigated this path over the last 19 years, is there a long-held belief that you've had that you recently changed?
Yeah, for a long time, obviously I worked in classical machine learning and data infrastructure back in the day, then enterprise AI, and then worked with the labs in post-training of LLMs. So for a long time, I have been a very strong believer in the power of AI, starting with classical ML back in the day. And with the advent of LLMs, I was of the opinion that this is going to radically transform how things happen in the enterprise. And yes, it is starting to happen. But, things have taken slightly bit of a backseat. And what I mean by that is, yes, things are going to be transformed in the enterprise, but it is not going to happen without some amount of handholding. And what I mean by that is there is tremendous opportunity right now for businesses to build up consulting arms that's going to help drive AI adoption in the enterprise. Particularly in the industrial space, we still have a lot of companies who are not particularly educated in AI, who are not very familiar with, okay, what does it mean for long horizon problems? What does it mean for agentic workflows to be resilient and robust? What does it mean that, okay, LLMs are basically a token prediction probabilistic system? So, and we see this happening in the industry with the frontier labs, and even the FANG companies. They're building out these really FD arms, or rather consulting arms, that's going to go out there and then really build out these AI solutions for enterprises. So I've changed my mind that, okay, AI is just going to be self-driving and organically get adopted to, it's not going to be organic. It'll need some amount of hand-holding from experts to make things happen in a robust and reliable manner.
I think a lot of people are starting to come to that conclusion, right? There's this belief that AI is going to do anything and everything, but really do need expertise in the loop.
Yep, absolutely.
So you've been involved really in the infrastructure, the plumbing that not a lot of people really pay attention to because they see the shiny object. So what does the infrastructure builder see that the model-obsessed crowd misses?
Well, the model is the last mile. The model provides the reasoning ability, but infrastructure is everything around it. So the model, for the model to be able to reason over something, that's something the data needs to be constructed in a particular way for the model to be consumed. There needs to be data pipelines. There needs to be intelligence distributed across the whole stack, not just concentrated in the model. So yes, while the model does the reasoning, the model of its own is completely powerless unless it has the stack feeding it data, unless it has the stack with being able to draw inferences from production data and so on. So I think about AI as a system as more of a data processing problem rather than a inference problem. Inference is just one part of it, reasoning is one part of it, but surrounding all of it is just a data processing problem. That's the way I think about it. And of course, the other part is, models can do reasoning, yes, but we cannot undermine the need for reliability and robustness, particularly in enterprises and particularly in critical infrastructure domains where I've spent over a decade working first half of my career. Because, if I go and ask an LLM, hey, who is Bill Gates? And if it tells me Bill Gates is the CEO of Tesla, all right, big deal. It's a Q&A, I can figure it out. But if that kind of mistakes happen in a critical infrastructure environment, there can be catastrophic consequences of it. So the infrastructure surrounding the model, building it in a way where data processing happens in a reliable and robust fashion, that's extremely critical.
So then from your perspective, because you're spending time on the data, other people are focused on the models, but when it comes to enterprise AI initiatives, why do you think they fail more often than not? What's causing it?
Well, the biggest pain point I see is enterprise AI is failing mostly on long horizon problems. And that's to do with really some inherent limitations in LLM architecture. So LLMs obviously just context windows. And nowadays we hear a lot about, okay, context windows are increasing, there's 10 million size. I even hear some people talking about infinite context window. But mathematically, there's no getting around the accuracy problem, even with increasing context window sizes. So enterprise AI fails in long horizon problems because as the workflow gets longer and longer, the accuracy that the model can respond to a particular question or a particular input, the tool calling accuracy, it tends to decrease. So being able to account for all of this is extremely important, and which is why now in the industry we see a plethora of these AI memory startups. And I myself spent a few months at my last gig working on AI memory. So there is certainly a lot of scope for enterprise AI to succeed on long horizon problems by ensuring that there is appropriate context engineering, ensuring that there is appropriate understanding and management of the AI memory problem.
So what have you learned from all this that people that are in the Gen AI world, they're so focused on the large language model applications? What would you want them to know if they don't?
Well, it's not a silver bullet. I think people tend to forget that LLMs, at the end of the day, they are highly probabilistic, yeah, they're pretty cool. They can do a lot of things which back in the day, rules-based engines it just don't hold a candle to. But reliability is extremely important. So understanding the limitations of LLMs is very important. One, that it is probabilistic. Two, that context windows are an inherent limitation. Three, that even with large context windows, mathematical limitations exist. And then understanding and knowing how to build around, how to architect around these limitations, that is extremely important. And this goes back to the point I was making earlier. And this is where having experts who understand these limitations and who can actually architect AI systems around these limitations is extremely important. And that's where even the frontier labs, they're coming around to it, and which is why they're putting billions of dollars in building out these consulting arms.
So what would make the models both probabilistic and deterministic?
Well, LLMs by nature are probabilistic. Some might even say stochastic. So for models to be deterministic, well, there will have to be new architectures. LLMs are not, by nature, LLMs are probabilistic. They are not deterministic. However, we could use LLMs for reasoning, and they're really good at that. And we can build an AI system with determinism, accounting for the probabilistic nature of LLMs, and trying to build resiliency and robustness through some determinism. And there are some architectures for that. For example, there can be, mixture of experts. There can be multi-model architectures where one model is providing an output, another model verifying. So there are architectural patterns around it. And the other is also making sure that there's verification models of when a model provides an output. And at the end of the day, there's also things that one can do in a particular domain to fine-tune a particular model. So, so in the post-training phase, it gets a little bit more accurate in a certain domain. So there are techniques that can be used to get around the probabilism, but LLMs by nature are probabilistic. So unless a new model architecture comes up, we cannot say that a particular model is deterministic.
How could you get it there, though?
You mean new model architectures?
Okay.
Well, to my knowledge, there haven't been any developments in new model architectures towards determinism. Now, there have been a lot of talk in terms of world models. I think Jan LeCun is a big exponent of that. We even see in the physical AI domain. And in fact, a company, I think I forgot the name of the company. The gentleman, the CEO of the company, recently posted a pretty interesting blog post in LinkedIn. He runs a physical AI company, and he was basically talking about how determinism for physical AI is also extremely important. Just like I mentioned the point earlier that a small mistake can be catastrophic. So he was also leaning in favor of world models as well. So, but again, this is very early stage. We are still at the research phase of it. And one thing to understand is, the way these things work, researchers put in the legwork and then industry reaps the benefit for a few years. So the research in LLMs happened several years ago, back in, from say in the 2010s. And now it's late 2010s to now onwards, in the industry is reaping the benefits of it. So the research is happening now in what's next. How can we make models more deterministic? But that hasn't been commercialized yet. So I'm optimistic that given the pace at which things are happening, probably in the next 2 to 3 years, we'll start seeing some of the outputs coming out of the labs and in the industry and in commercialization, whether it's in physical AI or whether it's in enterprise AI.
So why do you think it's so hard? I mean, everyone talks about knowledge and data, their knowledge, and getting it into the large language model so they can start using it. Why is it so hard for companies to get their knowledge into these LLMs so that they can make it more actionable?
Well, one of the problems, the economics of it as well, where enterprises have tremendous amount of their own the documents, their own knowledge bases, their code bases, tribal knowledge, and now we're seeing call recordings and whatnot. So feeding all of that into LLMs is just extremely expensive, and we are seeing this happen. I mean, the industry shifted very rapidly from token maxing to token optimization. So there's definitely some scope for doing compression in terms of how information is being fed into LLMs and also how LLMs are outputting. So there is some scope there in terms of doing, and there's some literature out there in the coming out of academia, like in terms of, say, whether it's Refrag or Pisco. I think even Apple research has done some interesting. I think they're calling it Aurora, if I remember correctly. So there's research out there coming out of academia, but some of this is yet to be commercialized, where the benefits of compression can be seen in a much discernible fashion. It's happening in bits and pieces right now. Then not beyond the scale of the data, there is also the accuracy aspect of it, right? So if a organization has, say, 10 petabytes of data, and then feeding all of that data into a RAG or an AI memory system, and then having an LLM reason off of it is a non-trivial problem. So there's tremendous amount of optimizations that need to happen. So right now, what I can say is that the early stage AI memory startups, they're mostly focusing on the episodic aspect of it. And what that means is, say, you and I are having chats with LLM. So how do we ensure that the context of the chat number 1 is retained when, say, 10 days later, I'm having chat number 59? So that, but in the context of enterprises, it's well beyond episodes. There's knowledge graphs, there's knowledge bases, there's code bases. So integrating all of this from 10 different systems of record, making sense of all of it, and then providing answers, providing ability for agents to build workflows off of this with high accuracy, that is a non-trivial problem. And this non-trivial nature of it is compounded by the economics of token costs of LLMs. So that's where all of this comes to, which is where the rubber hits the road, basically.
Yeah, I've spoken a lot about that lately. Just we're going to see this massive spike of spend over the next 2 years on tokens until the market resets, either from one of the established competitors, will do something, or a new market entrant will come in. But we haven't quite reached the point yet where businesses are unwilling to spend. But like all things in supply and demand, right, we're going to hit that point. But yeah, I mean, I think people want to use these models more, but at the same time, there's been the hesitancy to really embrace more AI because they know there's going to be this variable cost. And businesses, it's not that they don't mind investing, they don't like not knowing what the investment will be if it's unpredictable.
Right. So the cost is one factor. The other factor is also the more philosophical aspect of it, which is the intellectual property, right? So if I am running a company, I have my company's IP, intellectual property code, and all of that. I'm feeding it into an LLM. What happens with it, right? I mean, I may have a contract with the LLM provider, but if I'm a $5 trillion company like Nvidia, for example, they have specific instances of a coding model from one of the frontier labs. Not everyone has that kind of muscle. So what, right? So there's the intellectual property aspect of it as well, and you can hear some of the industry leaders talk about it. Like I think Alex Karp, CEO of Palantir, he talked about it recently as well. Of course, he was seeing it from the perspective of his company, but there's still some logic to what he was saying. And in fact, even Satya Nadella made the same point fairly recently, that do we want to have very few AI companies eating up the economy? So something along those lines. So the economics of it is one aspect of it, and the other aspect, of course, is the intellectual property aspect of it.
So the tokens are more expensive, but the models themselves get cheaper. And aside from the difficulties of getting knowledge built, the intelligence is there in each successive release of the models, right? So if the intelligence, you could argue, gets commoditized with each iteration of the model. So doesn't a lot of the data engineering work that you've been spending so long building also get commoditized, or?
Well, data engineering is, let me put it this way. Some aspects of the data processing, some aspects of the AI system engineering will get commoditized. Yes, I agree. So for example, what may get commoditized is, okay, how do I create this data ingestion pipeline? Okay, what does the data model look like? How do I do, say, data cleansing? I mean, that stuff is going to get commoditized, and it's already happening. What may not get commoditized immediately is the judgment aspect of it, right? Say, what's worth collecting? Okay, there's this 10 terabytes of tribal data that a company has collected over 40 years. Okay, what percent of it do we actually want to feed into the model and what not? And then building architectures that's going to compound over years, that's not get commoditized. That's still knowledge that people have in their heads. Now, given the pace at which the industry is evolving, and as you rightly said, given the pace at which the models are getting better, I mean, it's very possible in 1-2 years, even the things that I said are not going to get commoditized now, some of that will start getting commoditized in a couple of years. So it's a whole new world. I mean, the pace at which things are changing, it's just completely unprecedented.
Well, it's definitely a very shifting landscape for sure. So there's a lot more talk as agents start to work their way into mainstream, that the future of work is going to be about managing AI agents or managing AI agents with people. Can you point to anyone running right now reliable agent fleets in production, or is it still mostly a demonstration?
So I think it's mostly demonstration. Reliable agent fleets, I think reliable is the key word. There are several companies running agent fleets, and this goes back to the point I mentioned earlier, where enterprise AI is failing in long horizon problems. Where, yes, agent fleets can run, but with reliability, that's the difficult problem to solve. Because, I mean, I can have an agent or agent fleet run over a problem for, say, 5 minutes. But if I have a long running problem that it needs to run a workflow for, say, 2 hours or 3 hours, how is that going to work out? I don't think there are many companies out there that's actually able to do that successfully. Which is why enterprise AI, agentic AI pilots look really good, but when the rubber hits the road, when it hits production, particularly for long horizon problems, strong running workflows, that's when accuracy suffers. That's when the ROI doesn't really meet what the sales pitch may have been. And in fact, if you look at the position paper that came out of MIT, I think this was a few months back. I think this is what they were talking about as well, that with long-running workflows, that's where enterprise AI is failing. So to answer your question, yes, agent fleets are running in production, but reliably over long-running workflows, not as much.
So then, given that gap between pilots and actual sustained production, then what is it that most people are getting wrong about this? Why is it so hard?
I think where people are getting wrong is a lot of people are thinking about AI as a silver bullet. It's not. Where people are getting wrong is how to build these architectures for long running workflows, for long horizon problems, how to build resilient and robust AI systems, how to actually build these systems while being extremely aware of the limitations of LLMs. Yes, LLMs are great, but they're also, like I mentioned earlier, they're probabilistic systems. So I think architecting these systems is where people are getting it wrong. And what other thing that's going on is now with this agentic coding, people are building all sorts of vibe coded AI applications without really thinking about things architecturally, without really thinking about the fail path and how do I actually make things resilient and robust for the fail path. So I think that's where the gap is right now, and that's where there's an opportunity for a lot of companies to actually go build out consulting arms, and that's what we're seeing happening in the industry right now.
That's funny if you think like the CIO was pulling his hair out before, with people buying, random SaaS applications or something and bringing them into an environment. Now, people are vibe coding and building things. Who knows what's happening in the enterprise, right?
Yeah. And a lot of these vibe coded, don't get me wrong. I mean, in a way, I think it's good that the barrier to entry for building these applications has come down. But an engineer who knows what he or she is doing can be 20, 50x more productive. But somebody who doesn't know what they're doing and just vibe coding, it just creating enormous amount of tech debt. It's just introducing bugs and whatnot that somebody will have to come back and clean.
And inherently harder to manage, right?
Yes,
especially with agents, that are crawling across APIs and MCP layers and things like that. It's not like you could just simply turn off an application or remove someone's access.
Exactly. And now, you mentioned context engineering earlier. I think now also beyond context, there's this thing called loop engineering that's happening, where the idea is that you have coding agents go around, or any sort of agents go around in a never-ending loop until it's like a control system back in the day, until the control algorithm actually determines that, okay, now I'm happy with the output. So again, if people know how to build these things, you could really build some really cool, sophisticated systems. But just vibe coding these things is just setting a company up for failure, in my opinion.
So if intelligence does start to become more commoditized, at least if not more accessible, everyone starts orchestrating. A few years out from now, 5 years, 10 years, what's the durable advantage if businesses can get their arms around this pretty easily?
I think durable advantage would be proprietary data. So if I have my own company, my company's IP, proprietary data, that is my advantage. Then deeply integrated workflows, that's going to be my advantage. So AI as core in my system and not bolt on. And then really also the other is operational discipline, where I think about governance, I think about building robust and resilient AI systems. And then essentially where AI is not bolt on and my system is by nature AI native. So data, integrated workflows, and then really operational discipline. That's the way I think about where the durable advantage may come from in the next few years.
There's talk about AI becoming the glue or the operating system. So for a company that actually can achieve this, what would that look like?
Well, AI native companies, and we're seeing this a lot out here in the Valley in some cutting edge startups. Well, AI has to be embedded in every single decision loop. It's not bolted on as a feature, right? So the way I envision this, where we have a platform, let's put it this way, and the platform is the brain for everything the company does. So, okay, so we are on a call, the call recording automatically gets integrated into this AI brain. It gleans insights from there. At the same time, this brain integrates with Slack. There's some conversation happening in a Slack thread. That integrates with, say, Jira or Linear or the code SLDC system. And based on all of this, it takes immediate actions, right? So maybe I got on a call with a customer. Within a minute of the call completing, the recording gets ingested. AI immediately figures out, hey, wait a minute, based on this recording, this new ticket needs to be created. It creates the ticket. It posts a Slack message to the engineer saying, hey, I created this ticket. And in parallel, it also goes and submits a PR in GitHub and says, hey, here's a PR, engineer, go and review the PR. So that's truly AI native. That's how AI becoming the operating system. That's how I see it.
I mean, I think that feels more tangible the way that you're describing it, right? You're like, oh, okay. Yeah, that feels grounded.
It's doable. I mean, it's very doable. And in fact, there are companies out there, there are startups out there that's attempting to do this. In fact, even in my last company, I had built an internal platform to do exactly this. So definitely, it's definitely doable. There's no question about it.
So now that you've been doing this for a while, what do you see as the gap between what AI is promising and what infrastructure can actually deliver today?
Well, the gap I see is, the demo, as we discussed earlier, the demo and the pilot versus the production distribution, right? So really building robust, resilient AI systems for long-running workflows, for long horizon problems, that is extremely critical. Then the cost is that's going to come back to roost, and we are already seeing that, because the VC subsidized token cost, that's not going to last forever. We saw this with Uber, we saw this with the rideshare companies, and we're starting to see this with the model providers as well. So that's the gap. And then the other gap is really the feedback loop, right? So feedback loop is, okay, having eval harnesses from the get-go, and then retraining AI based on these evals in production, doing online training of models, doing online post-training of models. And then having the feedback loop in a way where it's not an afterthought. So I think these are some real gaps. So long-running workflows, long horizon problems, the cost factor, and then of course the feedback loop. These are the three important gaps as I see it.
And finally, I guess, what are you focusing on right now that most people aren't when they should?
Well, I have a couple of things on my radar. So as you mentioned earlier, I am kind of exploring my own thing. So myself and my co-founder, we're looking at a couple of ideas. We're still in stealth, so I hesitate to talk about. So we're obviously in AI, but we're looking at a few things, a couple of ideas, and and we're hoping to come.
I thought you were gonna open up a pizza restaurant or something.
Well, that's always an option, right? If we build a startup in a way where everything is completely AI native, then then everything AI runs everything, then I can go run my pizza restaurant.
Well, there you go. Really, really good to see you, my friend. So thank you for being on Unscripted.
Thank you, Jeff. Happy to be here. Thanks for having me.
Come back soon.
All right.